All right, so this is page 2 of your test review. So I'm telling you people, when you're given a graph and stuff like this, I expect you guys to plug that into the calculator. If you don't do anything else, copy what's in the calculator onto your graph and get some numbers and put some effort into it. Okay, so I'm going to look at this and I'm going to plug in my y equals 2 raised to x plus 3. And I have to get back down to where it's not in the exponential minus 8. So there's my equation. I'm going to graph and see what it looks like. Okay, now I'm going to know your asymptote. Let's just say your asymptote is going to be this number. Y equals -8. You can automatically put that in. This is your K value. That is your asymptote. So when we talked about you do this. Oh shoot, I didn't mean to do that. Here we go. A, B, this is x minus h plus k. So here's your transformation. Right, your h makes it go left and right, your k makes it go up and down. So we know that this is making the asymptote go down from 0 to -8. So your asymptote is always going to be y equals k. So you should be able to get that part of your test if you're looking through this. And your b value in this one is 2. So b equals 2. 2 is bigger than 1, so we know we've got a growth. Okay, right there. You can do these. Okay. Now the rest of the stuff, I suggest you go ahead and just put it in your calculator and look and see what you've got. So when I'm here, I can try and guess, but why would I do that? I can just go to my table and start looking at the numbers. Now, here's what I'm going to recommend. Find numbers that you can work with. I'm not going to be able to work with these as easily as I'm going to be able to work with these y values. I'm not going to be able to work with 120 on my graph. I'm not going to be able to work with 248 on my graph. But I can work with these smaller numbers, -7, -6, -4, 0, 8. So let's use those. All right, so I'm going to go ahead and create a table because I think you should do this on your test every single time. And use the numbers that work for you. -3, -7, -2, -6, -1, -4. Do I expect you to do all of these? Not necessarily, but I think you can. There's no reason you can't and shouldn't. So, -3, 1, 2, 3, -7, 1, 2, 3, 4, 5, 6, 7. Then I've got -3, 1, 2, oh, I just did that one. -2, -6, -1, -4, 1, 2, 3, 4, 0, 0, and 1, 8. So then I'm looking at that and I'm thinking, well, I don't know. And I'm going to look back at my graph and see, well, wait a minute. I did not graph my asymptote, which I should at -8. 1, 2, 3, 4, 5, 6, 7, 8. This is going to be a horizontal line at -8, right? Hoi is a horizontal line. So we've got this horizontal boundary right here that the graph is not going to cross. So we've got, and there is my graph. And that looks very good. So what I'm going to say is there's no reason you should not get this part. even if you can't get this stuff, which I think you should be able, you've got a graphing calculator right here. All it takes is finding some whole numbers and figuring it out. Now, some of them are not as easy as others, I admit, but you should be able to do this. It only takes willingness on your part. Now, my domain is going to include, when I'm looking at my domain, right, my domain is my x values. Which x values are covered? Well, this arrow is going this way, this arrow is going that way, so it's all real numbers. It's going to be all real numbers. My range bottoms out at y. So my range is going to be y is greater than 8. Not greater than or equal to, because it's never going to equal 8. That's what the board, this is my boundary. It's never going to touch that. And notice these are always going to be the same. The number for your range will always match the number of your asymptote. Okay, if you're going to get it right, that's what's going to happen. Just keep in mind, sometimes it's going to be greater, sometimes it's going to be less than. But if it's above, y is greater. And we'll talk about it when it's below. And then the y-intercept. Boom. I can at least get that right. 0, 0. What is y when x is 0? Okay. So that's what I'm saying, is even if you get stumbled up on something, you should be able to create your table, give me your y-intercept, give me your domain, and then hopefully you can figure out your range and your asymptote. All right, moving on. So this one, look right here. This is my k value. I don't even have to do anything. Y equals 5. Boom. Then I can even go ahead and graph it. 1, 2, 3, 4, 5. Now, when you graph this, you better make sure that that's going to match. So I'm just going to double check. Negative, and I'm going to put in parentheses, 1 divided by 3 in the parentheses, times 6 raised to the x power. There's no horizontal shift, plus 5. Graph. And sure enough, at 5, my graph is leveled out because it will run along this line but never touch it. So now I'm going to go and do my table. And I know that the most interesting numbers are going to be right in here, because I don't need all these business. I don't need all those numbers. What I need are these numbers. I know how the graph is going to behave over here. Where is it turning, and at what point does it start to increase or decrease? So I'm going to go to my, and I see these are very difficult numbers to work with. I don't need to worry about that. I am going to need my x0 at 0, 4.666 repeating. Do I care that that's a decimal point? No, the calculator's calculating it for me. Doesn't matter to me. I can write a decimal point. All right, so I'm going to start with 0, 4.66, 1, 3, 2, -7. I can't graph -67. These points should be good enough for me to figure out what this graph looks like, because I can see it right there. So now I'm going to graph 0 at 1, 2, 3, 4, almost 5. Boom. 1, 1, 2, 3. And 2, -7. 1, 2, 3, 4, 5, 6, 7. So now I can draw my graph to resemble this. And there you go. Full credit. Yay! All right. My domain, again, all real numbers. It's all the numbers on the, so my domain's going to be all real numbers. my range stops at 5, right? So y has to be what? Less than 5. Not less than or equal to. You will be marked off if you put an equal sign underneath there. And look, you've done almost all the work now. And I see that the b value equals 6. And I see that 6 is greater than 1. So this is a growth. And you're going to say, wait a minute, Ms. Lavelle, it's going down. And that, in my view, is a decrease. That is a decay. And I'm going to say, you're right, it is going down. But it doesn't ever bottom out. It continues to go down in the negative level, which means it's continuing to increase at a negative, into the negatives. It doesn't bottom out. It doesn't bottom out below. So it's from left to right. Remember, we read from left to right. It is increasing at a negative pace. So all you need to know, if that's confusing to you, is you look at your b. Is your b greater than 1? If your b greater than 1, then it's a growth. Okay? All right. Here we go. This one, I'm going to look at this right here. Boom. That's my k. I know that y equals k for my asymptote. Y equals -3. Oops. You might want to see that. Sorry. There you go. Okay. Now, you can also look at your b value. This is your b value. This is your b value. B is 1/2. 1/2 is smaller than 1, so is this going to be a growth or a decay? It's going to be a decay. All right, let's see what this should look like. Let's see. I'm going to try and do, there we go. So I'm going to clear that out, and I'm going to again use my parentheses. You can use 0.5 if you want, but just for purposes of the video, raised to x plus 4 over here minus 3, and then graph it. And look at that, it's a decay. Boom, it's bottoming out at the bottom. It's bottoming out. The other one didn't bottom out at the below. It was increasing. All right. So I'm also going to notice right around the 0, that's not interesting. That's not interesting numbers right here, because I know that my y equals -3. 1, 2, 3, my hoy, my asymptote. Please graph that. Please just graph that, you people. Sweet, sweet, sweet people. All right, graph that. Now, I'm going to notice that where it's interesting is here. That's where I want to see it. So I'm going to kind of, when I'm looking at my table, I'm going to look at the x values, maybe around -3, -4, -5, -6. Those are going to be the ones that are the most interesting. So I'm going to go to my table, x, y, and I can see these are all very, whatever, I don't really, that's not super helpful. At -3, -2.5, I can kind of wrap my head around that. -4, I've got -2, that's certainly helpful. -5, I've got -1. Oops. And then I've got -6, 1, right? And -7 is 5. Now it's going to just start increasing at some crazy. It's going to start getting bigger and bigger. So at least I've got some good numbers right here that I can work with. All right. Now, one number that I didn't get on my graph is where x equals 0. X equals 0 is my y-intercept, and I don't care that it's a big, huge decimal point. I'm just going to write it down because that's what they want to know. So here I go, and there you go. Imagine that, full credit for that. Woohoo! All right, so I'm going to start plotting my points. -3, 1, 2, 3, -2.5. So that's about right here. -4, 1, 2, 3, 4, -2. -5, -1, and you'll see it starts increasing over here. -6, +1, -7, 5, did I count that right? 1, 2, 3, 4, 5. So now I've got these, and I know, okay, that makes sense because my graph looks like that. And if I draw my line, it's going to actually match my graph. And I can see that. 1, 2, 3, that's right about the 3 line. Okay. Now, my domain, surprise, surprise, all real numbers. My range, look at this. Y is going to be greater than -3. Isn't that interesting? How these two are always going to help one another. Okay, so hopefully you're getting this. I think I've got one more. And then we'll finish up to 15 on this video, and then we'll do one more video for the last page. So here we go. Again, boom. This is your K value. My asymptote is Y equals K. Y equals 1. And I can go ahead and graph that. That's going to help shape my graph. That's going to help shape my graph. So we've got, and we see that B is 2/3. 2/3 is less than 1. So it's going to be a decay. I also see this negative sign, which means it's going to be another reflection. I'm not worried about that right now, but just kind of a heads up. So I'm going to, at this point, I'm going to say, all right, I'm ready to graph and kind of see what this looks like. I kind of have an idea. It's going to be a decay, so it's going to be going this way. It's going to be going, but then it's going to be a reflection, so it should be going this way. So I'm kind of getting an idea of what this is supposed to look like. So negative parentheses 2 divided by 3 parentheses times 3 raised to the x minus 7 plus 1. All right, now let's graph it and see what that looks like. And boom. Okay. Y'all, I made a mistake. This is not my b value. This doesn't have any exponents around here. This is my b value. Ah! Okay. That's my b value. So this is wrong. Okay, hold on. So my b value, sorry. I was hoping you guys would catch that, but nobody shouted it out. Oh wait, we're on video. Okay, so b is actually 3. So 3 is actually bigger than 1. 3 is bigger than 1. So that's going to be a growth, not a decay. So I'm actually expecting my my graph to look like this, right? But then it's reflected across the x-axis because of this negative sign, reflection. And so therefore, boom, it goes like this. It's still a growth. It's still a growth. Okay, so as far as where it gets interesting, this part's not interesting. This part's the interesting part, the curve, where it starts making the turn. So I'm going to kind of look at 1, 2, 3, 4, 5, 6, right around 6, 7, and 8. That's what I want to do. And did you notice that's actually right around? All right. where this is. Anyway, so we see at, we don't want that. We want, here we go. And you'll see up here it just evens out at 1 because the numbers get so small that it starts to get at 1. That's not correct. That's saying that it's touching this. It's really not. It's just moving right along that line. So at 8, we've got -1. At 9, we've got -5. Oh, and it's 7. Shoot, I probably should have done that. We got 0.33. So 1, 2, 3, 4, 5, 6, 7, 8. We've got -1. 9 at -5. And we know it bottoms out at 1. So there you go. So to find my x-intercept, I'm going to go where x equals 0 and find 0.9997. Okay. That's almost 1, but not quite. My range is going to be y is less than 1. And my domain, again, all real numbers. Okay, hopefully that is understandable. All right, last 2 on this video. So if we know that this, we're looking at this equation. Do you remember this one? We talked about it a little bit at the beginning. X minus h plus k. Here's our transformation equation. Okay. So if it's reflected, we've got f of x equals, if this is reflected, it's going to be negative 4x. And then if it's shifted 7 units right, we're going to do, we know that plus is left, minus is right. Is that right? I don't know, my brain's not working. Okay, so if we know we're going 7 units right, we're going to do minus 7 and up 9 units. So plus 9. Now make sure that this is in your k position, which is not an exponent. This is not an exponent. Not an exponent. And I'm going to just go ahead and graph that just to make sure that I've got it correct. I'm going to double check and say, all right, -4 raised to the x minus 7 plus 9. Graph that. And I'm going to see. There is my asymptote at 9, and it's moved to the right 7. Right 7, oops, you can see it's moved to the right, the curve has moved to the right 7, and it's moved up 9. Boom. Okay, I hope you guys check your work when you're doing these, and it's reflected, and it is reflected. You see that? Okay, so here we do the same thing. So f of x equals 4x. Now, it is vertically stretched. What in the world? This means that your a is present. Your a has not been present, so that's that number here, 3 times. That's your stretched. All right? And then shifted 5 units left, so plus 5, and 1 unit down. Let's use 1 unit down, so minus 1. All right, and then I would go ahead and just plug that in, pop it in. No need to wonder. 3 times 4 raised to the x plus 5 minus 1 graph. So now I'm looking to see, did it move left 5? Yes. Did it move down 1? Yes. In the stretch, it's hard to tell, but I think that's good. All right, hope that helps. One more video to cover the last